In this video, we're going to discuss about the rules of inference. So meron tayo ditong 9 rules of inference. So let's have number 1, addition or add. So dito, P, yung ating premise, tapos yung conclusion natin will be P or Q. So ano yung kapangyarihan nito? So ang kapangyarihan nito, kumbaga mag-a-add lang tayo ng isang proposition. Okay, so yun yung ibig sabihin nito. Okay, so yan yung gagamitin natin kapag gusto nating maglagay ng another proposition. Okay, kaya nga addition. Next, simplification or sim. So P and Q yung premise, then conclusion P. So dito naman, kinukuha natin yung first conjunct. Okay, so yan yung kapangyarihan ng simplification. So for number 3, conjunction or conj. Dalawa yung premise natin, P tsaka Q, then conclusion, P and Q. So dito, okay, kitang-kita naman natin, pinag-conjunct natin yung dalawang premise. Okay, next, modus ponens or MP. So ang premise, P implies Q, then P, then conclusion is Q. Mapapansin nyo, kapag may ganito tayong premises, yung isa P implies Q, yung isa premise nung isa. Okay? Then kukunin natin yung isa, yung conclusion. So yun yung kapangyarihan niya. Dapat may mapakita tayo na ganyan, tapos yung isa niya ay premise. Okay, so mamaya maintindihan natin yan kapag nasa example na tayo. Okay, so by the way, yung mga example pala nito ay sa next video na. The next, number 5, modus tollens or MT. That is P implies Q, not Q. Okay, so sa conclusion, not Q. Then, ang makukuha natin ay yung not P. Okay, so yan yung kapangyarihan ng modus tollens. Then, disjunctive syllogism or DS. We have not P or Q, then P. So, pansinin nyo ha, yung pattern. Yung isa dun sa disjunct, not P, yung first disjunct. Tapos, iba yung sign, P naman. Okay? Para makuha natin yung Q sa conclusion. Then, hypothetical syllogism or HS, P implies Q. Para siyang transitive, Q implies R, P implies R, yung conclusion. Constructive dilemma or CD, P implies Q, quantity, and R implies S, P or R. Papansin nyo ha, kinuha siya sa premise nung isa, tapos sa premise nung isa pa. Tapos or, disjunction. Then, for conclusion, eto na yung conclusion, Q or S. Okay, so yun yung CD, kapangyarihan ng constructive dilemma. Then, destructive dilemma or DD, eto naman, ang kinuha naman, so same lang yung isang premise, tapos dito, not Q, then not S, parehong sa conclusion ha. Then, pansinin nyo, or siya, ang makukuha sa conclusion, not P, tapos not R. Or, okay? So, bago natin i-apply yung rules of inference, so sa susunod na video na yon, ipakita muna natin yung proof nito using STTT. Okay, so for number 1, let's start with addition. So sa addition, meron tayong gagawin muna natin siyang propositional form. Argument form kasi yung given eh. So, para ma-convert natin sa propositional form, ano yan? Implication yan. So, ito yung conclusion, ito yung premise. So, P implies quantity P or Q. Okay? Tapos, using STTT, i-assume natin yung P logically equivalent to 1, then we have to show that P or Q is logically equivalent to 1. Okay? Then, as you can see, since yung P ay logically equivalent to 1 na, automatic na yan, wala nang ibang process, P or Q, kasi isa lang naman mag-1 dyan, automatic logically equivalent to 1 na sila. So, done, tautological implication, so valid siya. Okay? So, pwede natin gamitin yung 1. Next, yung 2 naman. yung simplification. So, gawin nating propositional form. P and Q implies P. So, i-assume natin P and Q logically equivalent to 1, then we have to show that P is logically equivalent to 1. But since yung P and Q, dali lang yan, no? Ay logically equivalent to 1, then automatic both P tsaka Q ay 1. So dito, mapuprove na agad natin na yung P ay logically equivalent to 1. So this is done. Tautological implication, valid. Okay? So hindi na pala natin kailangan pakita yung tautological implication kasi pala naman siya tautological implication. Valid na lang. Okay, so number 3, yung conjunction naman. Okay, so kapag dalawa yung premises, di ba, gagawin natin, ipagko-conjunct natin yung mga premises. Then implies yung conclusion. So P and Q, kitang-kita na, implies P and Q. So from assumption na rin, kapag inassume natin na P and Q, automatic, yung papakita natin, yun na rin. Okay? So, hindi na natin kailangan i-prove pala to, no? Kasi, kung i-assume natin na yung P and Q ay 1, automatic yung P and Q ay 1 na rin. So, wala na dito. Okay na yan. Valid din yung number 3. Walang pagtatalo dyan. Then, number 4. Try natin yung modus ponens. So, ito. Dalawa ulit yung premises. P implies Q and P. Okay? Implies Q. So, i-assume natin yung P implies Q and P ay logically equivalent to 1, and we have to show that Q is logically equivalent to 1. Okay? Now, since yung P implies Q and P is logically equivalent to 1, then P implies Q is logically equivalent to 1, and P is logically equivalent to 1. Now, since P is logically equivalent to 1, automatic yung Q ay logically equivalent to 1 na. Bakit? Hindi pwedeng mag-0 ang Q dito kasi kapag nag-0, 1 implies 0, magiging makukontra to. Okay? Kaya sigurado tayo na 1 pala yung Q. Okay? So, done. Valid. Okay, so let's try number 5, modus tollens. So dito, dalawa ulit yung premises. P implies Q and not Q. Bracket na. Implies not P. So we have to assume that P implies Q and not Q is logically equivalent to 1. And we have to show that not P is logically equivalent to 1. So dito, automatic, yung P implies Q ay logically equivalent to 1, and yung not Q is logically equivalent to 1. So since yung not Q ay logically equivalent to 1, then yung Q is logically equivalent to 0. At kung 0 yung Q, automatic yan, 0 na yung P. Kasi hindi na siya pwede mag-1. Pag magwa-1 yan, 1 implies 0, magiging 0 to. Okay? So, 0 yung P. At kung 0 yung P, then yung not P is logically equivalent to 1. Okay, so, sakto. Done. Next, number 6. Disjunctive syllogism. So, not P or Q and P. Okay? Implies Q. So, dito, i-assume natin yung not P or Q and P logically equivalent to 1, and we have to show that Q is logically equivalent to 1. Okay? So, dito, 1 to pareho. So, not P or Q logically equivalent to 1, and P logically equivalent to 1. And since P is logically equivalent to 1, then yung not P ay 0. So dito, yung Q ay 1. Okay, kasi kung 0 to, dapat 1 to kasi logically equivalent to 1 yung disjunction. Kaya 1 yung Q. So done, valid. Okay, so next is number 7, hypothetical syllogism. So yung premises natin, P implies Q and Q implies R. Okay? So dito ang conclusion ay P implies R. P implies R. So dito i-assume natin P implies Q and Q implies R logically equivalent to 1. Tapos we have to show that P implies R is logically equivalent to 1. Okay? So, kung conjunction to, ibig sabihin yung P implies Q ay logically equivalent to 1 tapos yung Q implies R logically equivalent to 1. So, may dalawang cases tayo dito kasi wala na tayong magagamit dito. No? So, parehong implication. Now, so for case 1, let P be logically equivalent to 1. So kung yung P ay 1, then automatic yung Q ay 1. Hindi pwede mag-0 yan. So yung Q ay 1. At kung yung Q ay 1, then hindi pwede mag-0 din yung R. Kasi Q implies R logically equivalent to 1. So yung R natin ay 1 din. So therefore, P implies R logically equivalent to 1. So okay na. No? So punta tayo sa another case. For case 2, i-let naman natin na yung P logically equivalent to 0. So kapag yung P ay 0, yung P implies R, automatic 1 na yan without knowing R. Kasi yung premise ay 0 na. Okay, so sa kahit anong case, the statement is true, P implies R, logically equivalent to 1. So this is valid. Okay, so next, constructive dilemma or CD. So ito yung premise or number 8. P implies Q and R implies S. And P or R. So ito yung dalawang premises. Then, yung conclusion natin, Q or S. Okay, so humaba na siya, no? So dito, let P implies Q and R implies S and P or R is logically equivalent to 1 and we have to show that Q or S is logically equivalent to 1. So dito, since conjunction ulit, therefore, yung P implies Q and R implies S logically equivalent to 1 and P or R is logically equivalent to 1. And dito, since ito ay logically equivalent to 1, then yung P implies Q is logically equivalent to 1. Then yung R implies S is logically equivalent to 1. Okay? Now, so dito, magkakaroon na naman tayo ng another cases. Kasi hindi na natin kulang to para ma-prove yung Q or S. So, magkakaroon tayo ng cases. So, for case 1, i-let natin na yung P ulit is logically equivalent to 1. So, if P is logically equivalent to 1, then yung Q natin, kasi since P implies Q is 1, yung Q natin is logically equivalent to 1. Bakit dito ako nag-target? Hindi dito. Wala na tayong pakialam dito kasi ang kailangan nating i-prove Q or S. So, isa lang mapakita nating 1 dyan, okay na eh. So, Q or S, logically equivalent to 1. So, for case 2, kapag nilet naman natin na yung P ay 0, then, yung R, automatic 1 yan. Okay, kasi yung P or R, 1 dapat eh. Kung mag-0 yan, hindi na yan magwa 1. At kung 1 yung R, so yung S natin, logically equivalent to 1. Okay? Kasi hindi pwedeng 0 to, 1 implies 0. Okay, kasi 1 yan. So kung S natin ay 1, okay na, Q or S. Logically equivalent to 1. So, from case 1, case 2, na-prove natin yung conclusion, so this is valid. Okay, so for last number destructive dilemma or DD, okay, so mahaba ulit yan, no? P implies Q and R implies S and quantity not Q or not S implies not P or not R. Okay, so dito, i-assume natin P implies Q and R implies S and not Q or not S is logically equivalent to 1, and we have to show that not P or not R is logically equivalent to 1. Okay? So dito, since conjunction ulit yan, so therefore yung P implies Q and R implies S is logically equivalent to 1. At ito, not Q or not S is logically equivalent to 1. Then yung P implies Q is logically equivalent to 1 and R implies S logically equivalent to 1. Okay? And then, wala na tayo ulit magagawa dito. Okay? Kasi disjunction, dalawang implication. Okay? So, meron ulit tayong cases. So, for case 1, i-let ulit natin dito sa premise na to, P logically equivalent to 1. Then, kung yung P ay 1, then yung Q natin ay 1. Okay? Kasi dito, hindi na natin kailangan yung ipakita yung not P. Kasi magze-0 naman eh. Ang kailangan na lang natin ipakita yung not R. Dapat 1. Okay, so saan natin tatargetin yan? Dito. Okay, related with S. Ngayon, para matarget natin to, dito tayo tatarget. Okay, so yung Q, logically equivalent to 1. So therefore, yung not Q ay 0. At kung yung not Q ay 0, yung not S ay 1. At kung yung not S ay 1, then yung S ay 0. Okay? At kung 0 yung S at yung R implies S ay 1, so hindi pwedeng mag 1 to. Yung R natin ay 0. At kung yung R ay 0, yung not R ay 1. Diba? Okay? Tapos, napakita natin yung isa 1, so yung not P or not R logically equivalent to 1. Okay, so ito yung karugtungan. So, okay yung case 1 natin. So, for case 2, ilet naman natin na 0 yung P. So, yung not P ay 1. Dali na lang. Okay na. Not P or not R is logically equivalent to 1. So, this is done. Valid. Okay. So, using STTT, napakita natin na lahat ng rules of inference ay valid. So, sa susunod na video, gagamitin naman natin yung rules of inference kasama yung rules of replacement para mag-prove kung valid ba yung isang